Okay, video 2. We're going to go through some examples. This example comes from 12C from Dominic's book. It's question 2a. It reads, solve the difference equation u of n is equal to 2 u of n minus 1 minus 1, and we're told in the question that u of 1 is equal to 4. Now, I know that there'll be two numerical values needed to complete the question because I'll have an a and a b in my general solution like that. So what I did is I put the u of 1 being 4, I put that into the equation, so that means u of 2 would be twice 4 minus 1, which is 7. So I got my second value. Okay, onto the question itself. So there's my general solution to all first order homogeneous difference equations. The k value is the number 2 in the original difference equation, so the k will become 2. And now what I'm going to do is I'm going to find what a formula for u of 1 and then a formula for u of 2. So the formula for u of 1 means instead of n in my general solution, I'm going to put in a 1. That will give me this. So u of 1 will be a multiplied by 2 to the power of 1 minus 1, which is 0, plus b. And we already know that u of 1 is equal to 4, so it simplifies to a plus b equals 4. I'm going to repeat that for u of 2. So I'll put 2 in for n. And my u of 2 works out as a multiplied by 2 to the power of 2 minus 1, which is just 2 in brackets there, plus b, and I know that that's equal to 7 based on what I had in the top right hand corner. That gives you my second equation. Now there are two simultaneous equations marked 1 and 2. So if I solve those simultaneous equations like you would just two equations of the line, you get values for a and b. And we just take those two a and b values and put them into the general solution. So that's the one that says u of n is equal to a bracket 2 to the power of n minus 1 plus b. We pluck out the a and the b, and we put in the 3 and the 1. And that's the solution for the difference equation given in the question. Okay, second example. So this is also 12C from Dominic's book. It's question 2b. The question was, solve the difference equation u of n is equal to a half u of n minus 1 plus 4, where u of 0 is equal to 16. Again, I know that I'm going to need two values. So if I have u of 0, I need to find u of 1 by subbing the u of 0 value in next to the half there in that. So u of 1 will be a half of 16 plus 4, which gives me 12. Okay, my general solution to start with. I know that my k value is a half, so there's my general solution. And I have a u of 0 is equal to 16, so instead of n in that equation, I'm going to put in 0. That gives me u of 0 is equal to a multiplied by a half to the minus 1 plus b, and I know from the top right hand corner u of 0 is equal to 16. So all I've done there is a half to the power of minus 1 is just 2, and that gives me 2a plus b is equal to 16. The second numerical value I have is u of 1, so I fill 1 into my general equation, general solution I should say, and I get u of 1 is equal to a into a half. 1 minus 1 is a half to the power of 0, which just works out as 1, plus b equals 12, so that's equation 2. And then I need to solve those again for a and b, and I put the a and the b into my general equation. That's the smaller box there on the top left hand corner. Gives me a solution like that. Okay, for you guys, do any of the questions from 12C question 1 and question 2 for practice, and we'll come back there in a few minutes.